Hi guys, Mr. Pfeiffer here. Today we're going to be talking about different ways of understanding motion. And in this part, we're going to specifically talk about using words and how we can translate that into what's called a motion map, and then how we can also go in the other direction. So without further ado, let's go ahead and get started. And in our first example, we're just going to use words to describe the motion. A man walks to the right at a constant speed of 5 meters per second. Well, we can also use what's called a motion map. A motion map generally shows direction and how fast something is moving. Now, the way we create a motion map is to first set an origin, pick a positive direction, label where the object starts, and then once it starts moving, we draw dots at equal time intervals. If it's not specified what the time interval is, go ahead and assume 1 second. Then we show the direction of motion by drawing arrows from one dot to the next. Let's look at an example of this. In our first example, I'm going to draw a man moving to the right from a position of -10 meters. He walks in the positive direction at 0.5 meters per second. So our 0 is already marked. We've marked where he's starting at time t equals 0. And now I'm going to go ahead and start the simulation. And I'm going to use a time interval of every 5 seconds. And we'll do one more. Alright, perfect. Now, let's go ahead and finish the motion map by drawing in from one dot to the next the direction that he was moving. Now we can notice some important things about this motion map. One, his direction is not changing, and two, the arrows are all roughly the same length. This is because his velocity wasn't changing. He was covering the same distance in the same amount of time. So take a moment, pause the screen, try to interpret the motion, and then we'll go over the answers. Okay, let's go over the answers. A. Okay, where was A starting? It looks like A started at, we're going to assume that these are each 1 meter, and that each time interval is 1 second because it's not explicitly stated. So, and notice they have a positive direction. So A is moving in the positive direction with a constant speed of, looks like under a meter every second. But, so we could say A is moving in the positive direction with a constant speed. And then you could say about a little less than a meter per second. B is moving in the positive direction or to the right with a faster speed than A. Notice the length of the arrows is longer. C is moving in the negative direction at the same speed as A, and it's also starting at 5 meters. In this problem, pause it, see if you can draw the motion map, and then resume it to see the answer. So here, we have to start by setting an origin. So let's go ahead and draw ourselves a 0 point. And we're going to just say that's where the squirrel is starting from at t equals 0. Then he runs for 5 meters per second. We'll call this direction positive. So he runs for 5 meters per second for 2 seconds. There's 1 second, 2 seconds. Then he stops for 3 seconds. So that's 1, 2, then 3, 4, 5. We represent stopping by just stacking the dots on top of each other, even though they would technically be like right here on top of each other. This way we can see it. Also, changing directions you'll want to do on top of it. So then we have, after 5 seconds, it goes 10 meters per second. So how long should we make it? Well, if 5 is this long, then 10 would probably be about that long. But it's 10 meters per second in the opposite direction. That's 2, 3, and we'll just kind of end it there. 4. Perfect. And this is the general sketch of a motion map. In this example, we're going to be showing acceleration in the negative direction. Our runner is starting here at the position of 10 meters. Pause this and sketch what you think a motion map would look like for the runner. Okay, now we're going to go ahead and solve this. So I'm going to start up. First, I have to mark where I'm starting, so I have that down. Then I'm going to start my simulation, and like before, I'm going to use every 5 seconds. So we want to know the first 15 seconds. 3, 4. All right, let's go ahead and take a look at what we've got. Now, I started here. My first arrow looks like this. Then I had that. Then I had one more. Great. Some things we can notice about this. First, all the arrows are pointing to the left, so his velocity was always to the left. We'll do one final example in a minute, but also notice that the arrows are getting longer, so it's covering more distance in the same amount of time, which means it has a greater speed. Go ahead and look at the last example and see if you can solve that one. In our last example, a man's running forward, he spots his X, slows down, and begins to run in the opposite direction. Sketch a motion map of what this might look like. So here we have our man starting at 0, and there's his X. And we are going to go ahead and do a little bit of sketching now. 0. And now we're going to push play. Play. 3, 4, 5, 7. Whew. Yeah, that was a little difficult to do on here, but let's go ahead and stop the timer and draw ourselves a motion map. So in this case, we started out here, going in this direction, and something happened, some slowing down. But since we're only using 5 seconds, we can only really use the data we have. And then we continued back in this direction, and then this direction. If we'd had smaller time intervals, you would have seen something like this. The arrows get shorter, and eventually it stops, and then the short arrows go the other direction, and then they get longer and longer in the other way. So hopefully you did well. If not, go back, rewatch the video. Feel free to email me or stop by my webpage. And I hope you enjoyed this, and thanks for watching.